Okay, 2004 integral is accumulator question. So this again is going to be a calculator problem. And one thing you should probably, when you're looking at your paper, I'm not sure if you can actually make out the entire function that's given to you. That f of t should equal 82 plus 4 sine of t over 2 for t between 0 and 30. So this is a question about a traffic flow rate. So that function is our rate function for this problem. It says traffic flow is defined as the rate at which cars pass through an intersection measured in cars per minute. The traffic flow at a particular intersection is modeled by the function f, defined by f of t equals 82 plus 4 sine of t over 2, where f of t is measured in cars per minute and t is measured in minutes. To the nearest whole number, how many cars pass through the intersection over the 30-minute period? Again, we have this consistent piece. How many? So we do how many, we want to integrate over the rate. So we will integrate over our rate function f of t over the 30-minute time period. So we'll go from 0 to 30. And then that answer, oh, by the way, this is to the nearest whole number, we end up getting 2,474 cars. For this question, this is actually a 3-point question this time. So they gave you 1 point for the limits of integration, 1 point for having the integrand correct, and then 1 point for having your final answer. So 3 points, a very doable question for that. Question B. Is the traffic flow increasing or decreasing at t equals 7? So this traffic flow, that is our rate. So what we're trying to figure out is the rate increasing or decreasing at t equals 7. If I want to know if the rate is increasing, I have to look at the derivative of the rate. So we want to find f prime of 7. Again, this is a calculator question. Have the calculator do the work for you. So what you'll do is you'll do math 8. You'll have your function in your calculator and you'll plug in 7. This will give us the value negative 1.872, or you could round it to negative 1.873. Since this derivative is a negative value, that tells us what our traffic flow is doing. It's because it's negative, we know the traffic flow is decreasing. And all we'd have to do is make a statement for that. So we'd say the traffic flow is decreasing because f prime of 7 is less than 0. Oh, we should add one more thing, at t equals 7. And this is just a 1-point question. And so the 1 point would be that you have that you say it's decreasing and you say why. So all that needs to be in there. Part C. What is the average value of the traffic flow? Average value of the traffic flow over the time interval 10 to 15. And now another thing we need to pay attention to is it says indicate units of measure. That means there's an expectation that you give a unit here. So average value of a function. Average value of function, we need to pull out this equation, which gives us the average value of a function. Now in this case, we want the average value of the traffic flow function. So what we're going to do is plug in our function f of t into our integral, and then 10 and 15 as our endpoints. So we're looking at 1 over 15 minus 10 times the integral from 10 to 15 of our function f of t dt. Again, we are using our calculators here. So all this number can be found on the calculator. It comes out to be 81.899. We need a unit for this. So this is a measurement that is looking at traffic flow. It tells us in the problem that traffic flow is measured in cars per minute. So our unit for this would be 81.899 cars per minute. This is also a 3-point problem. So we would get a point for having all this stuff in the front. So that would be a point. We'd get a point for the integrand. And we'd get a point for this number. The units, we're actually going to get a point for when we get the units right in this question and part D. Which brings us to part D. It says, what is the average rate of change? Average rate of change of the traffic flow over the time interval 10 to 15. Indicate units of measure. Average rate of change. For that, we're using this formula. Average rate of change is f of b minus f of a over b minus a. We're using that with our traffic flow equation. Remember what this does is this approximates the instantaneous rate of change. So this is like a derivative. So this is giving us a derivative, or an approximation of the derivative of our function f of t. So for this case, we'll do capital F of 15 minus capital F of 10 all over 15 minus 10. The number we get from doing this is 1.517 or 1.518. This question is only worth a point, and the point is just from getting this answer. Now, like I said in the last question, you're going to get points for indicating your units of measure for both C and D. They both have to be right in order for you to get the point for the units. Since this is telling us how the rate is changing with respect to time, the unit on this would be cars per minute, because we want to know how the traffic flow rate is also changing with respect to time. So we can write that as cars per minute squared.